In this video, we're going to calculate the expected value and variance of an investment. The expected value is the average payout of an investment calculated by using the probabilities of outcomes as weights. So here's the formula. P subscript 1 is a probability of outcome 1 occurring. P subscript 2 is a probability of outcome 2 occurring, and so on. And each of these probabilities, or you can think of them as weights, is being multiplied by the investment payout. The sum of all the probabilities must equal 1. And now let's talk about the variance. Variance here is a measure of data dispersion around its expected value. It is a measure of risk. Risky investments, in which the payoffs are quite volatile, will have a larger variance. If all the investment payoffs are the same, the variance would be 0. There would be no risk. And here is the formula for the variance. So again, we got these probabilities here. And in parentheses, we have the outcome minus the expected value. And all of that in parentheses is being squared. So here's a numerical example. We've got an investment. There's a 25% chance that this investment will pay off $200, a 70% chance that it'll pay off $300, and a 5% chance it'll pay off $500. So 3 possibilities here. You'll notice that the probability here in this middle column sums to 1, so the probabilities of all these outcomes sum to 1. So plugging everything into our formula, 0.25 times 200 plus 0.7 times 300, and finally 0.05 times 500. The expected payoff, or the expected value of this investment, is $285. To get the variance, here I have the formula on top. So plugging everything into this formula on top, we take the 0.25, and that's going to all be multiplied by the payoff minus the expected value. Okay, so we found the expected value is 285, and that's all squared. And then in this middle term here, the probability, 0.7, the payoff 300, again minus the expected value, and that's all squared. And likewise, we do a similar thing for this last term. So just simplifying here, 200 minus 285 is minus 85, 300 minus 285 is 15, and so on. Squaring those terms in parentheses and solving, we get a variance of $4,275. One thing to note is a variance cannot be negative because of squaring. So this minus 85, that's squared, so we lose the minus there, the negative. And another thing to note is more weight is placed on larger deviations from the expected value because of the squaring. One other thing we should look at is the standard deviation. The standard deviation of the investment is just going to be the square root of the variance, and just another measure of data dispersion or data spread. Bigger standard deviation, more the data is dispersed around its mean. And so we're just going to take the square root of the variance, and as we saw on the last slide, the variance with 4,275. So taking the square root of that, we get a standard deviation of 65.4. Okay, that's it. I hope you found this video helpful.